Logarithmic equations, we're going to do a couple of days on these just to get familiar with the different styles you may see in logarithmic equations. Today are all numbers that you will not need the calculator to solve for you. You can use the calculator to help you with arithmetic, but you're not going to come up with decimal answers. So, this first problem, you could see the logarithm show up only on one side. So this is negative 4 times log base 6 of r minus 1 equals negative 16. And so one thing I want to cover first is, oops, that wasn't supposed to be a line. Inside here, that number can never be negative. So the smallest number we can have in that R spot is what?
0.
Well, a 1. Because if R is 1, it'd be 0. So after the logarithm in this answer portion, it can never be negative. If you come up with a negative here, then you write no solution. There are none of those today. They will show up starting tomorrow. The whole problem will be no solution. Or it could have 2 answers and one of them be extraneous. So, with this, we need to get the logarithm isolated. So the log is the only thing on one side. What operation is being done to this side?
Is it multiplication?
We have multiplication and subtraction, but the whole logarithm is being multiplied. So we want to undo the multiplication first. So we're going to divide by negative 4 on both sides. So log base 6 of r minus 1 equals negative 4. Or equals positive 4, excuse me. Now, if you're at this point where you have just one logarithm, that's when you fish it, you convert it. So start at your base, circle around, come back through. So that's going to be 6 to the 4th power equals r minus 1. So what's 6 to the 4th? These are the things where you might need a calculator.
1,296.
1,296 equals r minus 1. Now, add 1. 12,097 equals r. You're done.
So we're just solving.
You're solving it, but the big trick is to get the logarithm first isolated, then convert it, then solve. About half your problems are going to be in this setup, where there's just a single log. Let's look at some problems where there are 2 logs. Log base 20 of 4n plus 9 equals log base 20 of 5n plus 4. For our purposes, I am going to have the same base on both sides. If they don't match, you have to do change of base. Change them to where they both have the same base. That change of base formula we worked with on Thursday, that's what you would apply. Not going to happen today. Today, you're going to see the bases match, and all you do is set the parentheses equal to each other if there's nothing else being done to the problem. So how would I solve this equation?
Subtract 4.
Subtract 4. Oh, you're going with the subtracting the 4? Okay, I'll do that. Subtract 4 and subtract 4n. We're moving both of them around. That's going to completely cancel out the 4n on the left and completely cancel out the 4 on the right. leaving us with 5 is equal to n. Now, check it. Is 5 being plugged into the parentheses going to cause either of them to be negative?
No.
No. So that is our answer. If it did cause one of them to be negative, you'd write in a solution. Let's do one more. So, what's step 1?
Put them equal to each other.
7x equals x minus 18. What do we do next? Move the x guy over, leaving us 6x is equal to negative 18. What do I do next?
Divide by 6.
If I plug negative 3 in for x, will it become, it will give me a problem. One of them will be, well actually, both of them will end up being negative. So, no is your answer.